can practice those concepts which we saw in AWT. I hope what we saw previously was if you have tried, I hope those the concept of inheritance, polymorphism. If you have not yet tried those programs, please try those. Yeah. So today we'll continue with what we saw yesterday, the concept of multi-threading. Let me share my screen. I hope you can see my screen. So yesterday we were seeing about the concept of multi-threading in Java, like the introduction, like what is thread, what is a process, or how this process happens in a system or a computer, and how can we use this threading concept in the Java program. So there are like various methods available. We'll see one by one what are those methods. The major one we will see here is like the thread class. So now in Java, at first we were seeing everything is like from the beginning we were creating like class and then variables, all those things. But later on we moved more into like object oriented. Like for a class, you will either import the class or create your own class or get the instance of a class or extend an existing class to create another class. So we created multiple classes and we used objects to access those class members as well as the class methods. But now we will see like similar thing here. Here what we want to do is like we want to split our task or our process into multiple chunks, which is called thread. So for that also we have a class in Java which is called thread. So it has a like lot of methods available to do these processes. We'll see one example how to create thread or how we can use this multi-threading operations in Java. So to start a thread, there is a unique life cycle for a thread, similar to applet life cycle. There is also a thread life cycle. So what we mean by life cycle is like it's like state, like from one state to another state. So usually what we do is like we have to just create a state or create the thread state. So it has 5 states. First one is new. That's like creation basically. Another state is runnable state, running state, and non-runnable, and then terminated state. There are like 5 states which we can check basically if a thread is there. If a thread object is there, with that object, we can use any of these state identification methods to identify in which state that thread is present. So new is our object creation spot where we will use the class name and then object name, then you will just create with a constructor. And to start any thread, we will call the method start. Yeah, thank you for recording. And sleep is one method which will like help you to slow down the process, or it will make the process to go to sleep. Same way there is another function called resume, notify all. So these are all like different functions which are there when the thread is not running, like in the sense which is in some other state. So the other states will be like non-runnable states, which will be like in these conditions. Running in the sense something like the thread is in process, like we are running that thread and you can see the output or what are the processes it is doing. In this case, what we mean by process are the statements which we give inside that block of thread. So there is nothing like different. What we mean by process here is not something which is like inside computer or something, but inside our program. And run to start the thread, and stop will like stop the thread or exit the thread basically. Like it's like termination basically. So these are the like steps, but these 5 are the states or life cycle which are present in a thread. We'll see what is those. So a thread is a new state if you create an instance of a thread class. As I said, it is used for creation of a thread object. So when we want to use the class, we have to create an object for the class. So that's the first stage or the first state, which is new. And this always comes before the start, because you have to have an object, then only you can start. So that's the case here. And runnable is like, it can be like this thread after creation, it has the capability to run, right? So it can be just called, or it can be started, so that start method is used for starting it. So that state is called as runnable state. Also, there are other things which is like scheduler. You can thread to run like if you think of like multiple threads we are creating in our program, you can schedule which thread should run, after that which thread should come. So that way we can schedule threads also. And running state is like when some process is running or some thread is running by executing some line of statements. Non-runnable is like when it is already running, you can't rerun it anyway. So that is why it is called non-runnable. So they become like not eligible to run basically, because they are already running previously. Like if you think like something like it exists previously, like when you create a password or something, it will tell you if they have the record of your password, it will tell you this password is already being used, right? So similar way here, this will tell you that the state where this thread is already running, so you can't use or you can't run the same thread again at simultaneous points. So that's where we have to split threads, and we can use the concept of synchronization. And terminated is that where there is no thread running. It's like it's over, or it's the end of that thread. So these are the 5 states or 5 stages of life cycle in thread class. So all these components is not necessary, but we have to create a thread that is new, and we have to have a thread should run. So we will be using start or run function to run that thread. I'll see an example. So there are 2 ways basically to create a thread or a thread object basically. One is by extending the thread class. Thread class is already defined in the Java program. One way is like we have to extend that class. Extending in the sense like it is an abstract class which we can extend it and then define our own things. Another way is to inherit, like implementing the interface of that class. Runnable is one class, interface, which can be implemented into our program for using it. And as I said, like, so what does the thread class has? It has constructors and methods to create operation on a thread. So these are by default present in the thread class. And what are the constructor methods available? One is thread, which is with no parameters. Another one is thread with a string name. Another one is thread with a runnable class object, which is R, runnable R. Another one is combination of both, a string name as well as a. These are the 4 constructors which is available for this thread class. And what are the methods available? One is run, or for running, or like to start the thread basically. This will start the execution of a thread. So what this start will do, this start will again call the run method only. you can see calls the run method on the thread. So basically, if you use start, it automatically start calling the run method, and the thread or the process gets started. And sleep is one method where you can specify the number, which is long is the data type, and millisecond it's the time which you want to give, so that it will sleep for the particular time. Like when you start, and then it will be inactive for the milliseconds which you have mentioned, then it will restart again. And join is used for joining two threads. Say we have 5 threads running. So you want to add that thread, one more thread to that queue, in the sense this more works like a queue case. Like one thread is running. So if you use the join method, the next thread will join when the first or the previous thread gets over. The process is dead. If the process is done, then it gets like it joins together and continues the process. If there are multiple threads in this case. And same here, there is another one which is join with a time specified limit. So it waits for the thread to get completed or to die, and then it just continues. The new thread continues to run. And another one is you can set priorities and get priority to a thread. Like get priority will return this value, basically the integer priority which we are giving. And set priority function, we can set what is the priority actually of the thread. And one more function is name. Get name, as the name suggests, it will get just the name of the thread. Set name is to set the name of the thread. And another function is current thread, which will tell you what are the threads which are running currently in your program. And ID is for getting the ID of the thread, like which is by default in the program. Each thread has an ID, so that ID can be retrieved by using this method. And state. So get state is another class which is present in the thread class. So that's why we are giving thread dot state. So get state will give you the state of the thread, like it is. It will show you it is running or what is the state, like running, runnable, all those things it will show you. And this alive will be telling like giving a Boolean result, like this true or false. Like if the thread is running, it will give you true. Otherwise, if the thread is dead and no more working, it will show you false. And yield is another function which will like execute the thread, and like it will pass on them some, like you can do multiple threading here, where you can execute the thread object and then just give some time to run, like it will like parallel processing kind of thing. You can allow other threads to execute. In the thread here, what we are telling, we are using the word thread. It's just the statements which you are giving in your program only. Here we are not going any deep into what a processing thread here is, but just from our program, what are the commands or lines which we want to execute as a thread. And suspend will stop or like kill your thread, basically. Like for it will just end the thread which is running, basically, and resume will resume this suspended ones. So this is like temporary one. This pause and play button kind of thing. You can pause for some time, and then you can resume that thread. And stop is like entirely stops. You can't restart this one, but you can recall again, like rerun from the beginning. You cannot restart left. You have to just create a new thread or start afresh. And this is another one. Daemon tools is one tool which is present. Will not look here. This we don't want. And set daemon. These are related to other concepts which will not look. Interrupt will be just a function where if the thread is running, we can interrupt the thread and then do some other processes in the middle using this function. And while running that, we can check using this function if that is the original thread is interrupted or not using this one. It will return a Boolean one. And the same here. This also returns a Boolean value. Here it is just interrupt, it is interrupt. That's the difference. And here what we saw is like we saw the concept like by thread class. So these all are present in the thread class, like the thread constructor, destructor, and these are the methods which are present already in the thread class. Other way is to use the interface, which is runnable interface. So as we so know that interface can be implemented to any class, where we can redefine the function or the method. So here the method one exists is called run. That is the only method which is there, and which can be used to start or initialize or to give set of commands in a thread or in a program, which will just execute them when a thread is created and then being called by this run function. So to start a thread, we use method called start. So this will start a thread which can run process which we are defining in our program. And once it is started, it moves from new to runnable state. Like in the case, like I'm not sure how many of you know about the GitHub concept where like when you push it, it goes to a state where it's not into commit, but it can be committed. So in that state, it's like it can be runnable. So that's why it is called runnable states. And when that is executed by using this run method, then what are the commands or statements which we have given? It will just try to execute. Then it becomes in the state called run state. So let's see a simple example of how to create a simple thread using a thread class. So multi is our class name, extends thread. So as we know that run method is necessary to run any thread. So we are just initializing or redefining basically here run, and what we are telling is thread is running. And this is our main method. And we are creating an object for our class, which is multi. And to start that one, so as we said, like if you want to run, you can just call the start method. So T1 is our object, T1.start. So if I do this, directly what is happening is like it is showing thread is running. So it is just start invoke this run method, and the run method gets executed here. So this is a simple way to create a thread using thread class. Any doubts, any questions so far regarding this creation of threads? We'll see the methods like one by one, how to use, where to use. Any questions, any doubts?
Sir?
Yeah.
Sir, as we can include many threads, it will occupy.
Yeah, right.
So if the memory is not enough, so can we handle that using some functions?
In this case, what we are trying to do is like we can, as we saw on functions like prioritization and all those things, synchronization will come later. So we can prioritize which process should run first. So this is more like we are setting up a queue kind of thing. So I want this process to run first and then continue this process like that. So in this case, memory always is a limitation for any of the thing, depending on your process or what you are trying to achieve in any program language. But allocation is like by default, it will allocate the processing power basically. It will allocate equal thread of processing powers to each threads basically. It will divide if you give multiple threads. I think you are asking about this processing power or storage memory.
Yes, sir. The memory, like how much memory is available.
So it tries to optimize this.
Okay, sir.
Yeah. Any other questions? You might think why have we have to use this? Because I can just simply create a function and create an object, right? That doesn't make, I mean, here it doesn't make any difference, right? Because this is the same concept which we saw from basic. Create a class, you can create an object and call the method, it will do the same thing. So why do we need threading? It will be a question again. Like we see next what we are going to do with threads, like how we can run multiple processes or multiple threads simultaneously or one by one, which it's more like how we want to use that programming concept to prioritize or like mostly to prioritize or take which process should run first. Like that is one of the advantage of Java threading. And why we need Java threading, that is one question. So if you want to do the same process on our own separately, then why we need threading concept? So one major one is like it just takes the optimization concept and it uses CPU in a better way to do the process separately. Instead of running everything at the same time, it tries to optimize your CPU usage as well. And the next thing is like you can divide the program separate into different threads. So each thread will have its own operation and it can be run separately. That is one advantage. Another thing is like this threading concept will be useful when we are creating some architecture which uses client and server nodes. Say, for example, when you have two operations performed at the same time, so you can assign it to a thread and then we can synchronize both threads, or we can like simultaneously a transaction is happening and that transaction can be tracked through two threads at a time. So that's where these threading concepts comes into place. We'll see the next one. So I think I did not show the brief. Yeah, this is by using the runnable interface basically. So this is by using thread class, which is like extending a thread class. So the same we can do by implementing this interface. So our class is multi3, implements runnable class, and we are defining this run method. And here what we are doing is we have to create a object for this runnable class and then use that object inside or to a thread basically. So thread, we have to create an object and then use that thread for this runnable interface. Then if you start, so it will work like same thing will come like, because it's not going to do a difference, but these two are possible ways how you can utilize. Again, the common thing between these two is like you have to create a thread object. So once you create a thread object, then you can utilize that object to invoke the method. You can see like if you are not extending the thread class in your class object, you would not be able to treat as a thread object. So you have to create an object. This is the thing. Then with that class, you can use this M1 object, which is object for the runnable class. Basically, a runnable class, but our class we have implemented, so it becomes multi3 class. Let's see next concept. Next concept is like scheduler. Like we can schedule a thread, but there is a catch here. We can create a schedule between 2-3 classes, but there is no guarantee that which will be chosen by this one, because it automatically the CPU usage chooses which should be taken, and only one can be run in a single process. It cannot like do this concept like together simultaneously. But this is used for kind of where when you want to split a program or a set of commands into time limit base, like first it should run this one and then this should run. So it's more like queuing method basically. So the thread scheduler uses these two approach. One is preemptive and then another one is time slicing scheduling. So like here in the primitive scheduling, the highest priority tasks executes until it enters the waiting room or dead state. Like in the sense like only the highest priority ones are given preferences first. In this one, like basically they just take based on your time you give predefined slice of time. So in this case, like the time which you give, say you gave that this one should take this much time, and I'm scheduling this should start in next 10 seconds, like that. Then it will start start that thread and keep that other thread in pause. But for primitive scheduling, it considers the priority which we are setting. So we saw two functions like set priority, get priority, all those things. So that can be used here. So another function, we are just looking at each of the functions which are present in the thread class basically. So another function is sleep. So what it will do is it will just make your process sleep for a particular time limit which you have mentioned. So again, thread class can be have two types of method for sleeping. One is sleep long millisecond. Another one is sleep long millisecond in nanos. So each one has two exceptions which can be thrown. Like one will show interrupted exception, same, and one also will show that. Why we are using this exceptions concept? Because when say you are when an existing thread is running and you are overriding or trying to run another thread, so you might end up with exception and it will throw an exception. So let's see how we can use this sleep method in program. So our class is test sleep method one, and thread is our class, and run is our function which is present in the thread class, which we are redefining here. What we are redefining? We are redefining as a for loop which runs for 5 times. I think not 5 times. It will start with 1 and it will end when it is 4. So it runs 4 times. And what we are doing is we are creating an exception block where we are telling thread.sleep is about 500 milliseconds. If there is an exception, catch that exception using interrupted exception and then just print that exception message. Okay. If there is an exception, try this one. If there is an exception, just print that exception name. And here we are just printing the numbers that 1, 2, 3, 4. And from the for loop, nothing we are doing here. And main method, we are creating two objects for the thread class basically. One is T1, another one is T2. So if you notice, this is the same class name as our own class, and only the object name is changed. So how do we start our initiate a thread? T1.start and T2.start. So what will be the output here? Any guess? Any question? Any suggestion? Any doubts? Or any guess for this program? What will be the output? Will this run? So basically what will happen here is like, so when we start, right, so what will happen? It will go to the run method and it will run this one. Like we'll see here. See, if you notice, it will invoke, but again we have kept 500 millisecond to sleep, right? So what is happening is like the second method is also being invoked in that 500 minutes because the first thread went to sleep. So the program utilizes that time to initiate and then start the next thread basically. So the next thread is printing 1. So that's why we are getting 1 1, 2 2, 3 3, and 4 4. So it's both are being invoked at the same time. Since we have set one thread to sleep for 500 milliseconds, so that time it is being utilized by the other thread to run its process. So we are getting the output simultaneously 1 1, 2 2, 3 3, and 4 4. So this is the thing. As we know, we can run only one thread at a time. But when you put it on sleep, the scheduler like picks the other one and then it continues to run. So the second one is being used here. So that's why we are getting the output as like this. Any doubts in this program? Any questions? If it is like this part, we are just moving a step further into utilizing other functions. Any doubts? Any questions? Okay, let me ask one thing. Where do you think we can use this concept? This concept, like, take this example itself. So, any place where you think this concept of threading can be used? Anyone just come up with some idea and we'll see where we can use this concept of making a process and then continuing it with the next step. Anything? Anyone? Anyone has any idea where how we can use this sleeping concept? Let's see. Today we'll see anyone has any idea to tell. So now we have a question, right? So I have two threads. I started them both, but if I use sleep, it starts one by one in the sense like the rest of the time which is utilized by the next thread which is invoked at the same time. But can I create a thread twice? Like what will happen if I do start two times? I say the same, right? Same usual one like a class name which is extending our thread class and run method which is redefined here, just running message. And we have created an object for this class that is t1 and t1 dot start and t1 dot start. So what can be the error or what can be the output for this program or this example?
Sir, it will overwrite it the first. Like here only running will be printed, but before the we go for second start, the first will already have been complete. So running will be printed twice.
Let's see.
Okay.
But there is a catch here. Why this didn't show as we expected? Because we did not stop this one, right? We did not stop this method. So it is still running. So we have an error, illegal thread state exception, because we can't start a thread which is already running. Even if you notice in the previous case, we created an exception for that. Like we used an exception which is called interrupted exception. Why? Because we are just want to try two threads which are different objects basically. If they had a conflict in the timing, so this will throw us an error, that is interrupted exception. But in this case, we are trying to add a method which is restart a thread which is already running. So that's why it just, the first one ran, but when we try to restart it again, what is happening is still the thread is running. Since it was not stopped or it was not paused, so what we are getting is an exception message which says exception in the main Java language, illegal thread state exception, because this is already running. That is the reason we can't restart a method which is a thread which is already running. So the next question what you can ask is like, yeah, if we are trying to simulate any operon, like operon, we can use sleep concept. Yeah, thread on could be there is no obstruction. This can be done, but again, how we want to implement that as a code in our program concept works. Yeah, the concept of lack and Swiss operon can be used. Like that is a interesting concept where it's more like switch on and switch off case. So here we can think like we can use the sleep concept, like we want to just yeah, as you said, like we can use that way, like we can use the sleep time based on some condition. Here in the previous case, we just used the sleep condition with nothing, right? Just we used thread.sleep, but you can add condition to this also. So here this is inside an exception loop, but as you mentioned, maybe like let's think of this way, like we have a glucose in our media and then lactose is there, like same concept of lactoperon if we think, or if you think of same concept like osmosis or some cell regulation where you find a threshold value. So if the threshold is above this, in case of threading concept, how we can do is like the first thread will consume a molecule and it will keep on adding. Once that limit is reached, then we can set it to sleep. So the sleep time also, what in sleep time, there should be a second thread which will be initiated and it should reduce that molecule. In the sense it is consumed basically. If the consumption is happening, so simultaneously after sleep for some time, so there will be reduction in that compound, right? So again, that compound will be added. Like so that way we can use this concept in case of biology, but there are other applications also. Yeah, this is one interesting concept to look on. We'll go. Yeah, here we were. Yeah. So whatever we are doing here is like when you start, it's just calling run method, like what we call the run directly. That's an expression in this site they are going to show us. So same concept, a method. So this is the concept. A thread starts in a separate call stack. So whenever you start, it is called, okay. So if you call the run method from the main current call stack, and then rather than beginning of a new call stack, so what happens you see? So this is a program here. We have a class name, and then the thread is our main one, which we are extending our class, and we are defining our run method as running. This is the main method and object for our class, that is T1. and t1.run. But this works like it just prints you like directly, like normal one how it works. It's not going to use any threading concept basically. If you just use the same way, it will just print the output. It's not going to leave an error message or anything. Just it will run. But what happens here is like there are two cases when you utilize from the main and when you utilize from the run. So here what is happening is just we are directly invoking this run method. It is not considering that it is called from a separate, it is called using an object or from the main class. Okay. So how we can see what is happening here? Since this is just printing running, we seems to know that okay, it works, nothing is wrong here. So same will do that by what we'll do create two objects this time, and then we'll try to use the run method instead of starting them. Okay. So test call to run is our class, thread is our original class, and we are defining this run method. What it does, it will just print 1, 2, 3, 4, and it will have a sleeping rate of 500 millisecond. And if there is an interrupted exception, it will throw that interruption and print it to us. Normally, it will just print the numbers. So in our main class, one object, second object. Instead of starting, we are just calling with run. So directly we are calling the method. Instead of using the start method, we are using the run. So what happens, you see? So if we start this way, it runs first and then it takes the next 1 second. You can notice that 1, 2, 3, 4 gets printed. 5 will not come, I guess. Five should not come, but let's try it. Why they have given 5?
Sir, the condition in loop, the for loop, it's less than 5.
Yeah, that's what I was saying. 5 should not come. Let's test here itself. Let's see if they are giving okay. It's the same program. Yeah. Yeah, the output there it is wrong. So it should print 1, 2, 3, 4. Here what is happening is like it won't run simultaneously as we saw like in the previous case. If you notice, when you use start here, what happened is like they were running 1, 1, 2, 2, 3, 3 like that, right? But here when you invoke this run, so directly we're calling the method, right? So it does not consider things of this as a normal function. What it does, it directly invokes this and executes the whole things. Since there is no exception, it is not showing an exception and prints the number like 1, 2, 3, 4. Then comes here and using the T2 object, it again runs that. So the thread sleeping has no effect here. So that is the thing. Like if you are using, you have to use start to call the thread instead of run. If you use run method, it will be considered as separate. There is no link between two of the threads. Any questions, any doubts? This output is wrong. So it should print 1, 2, 3, 4 only. So we saw how we can like use two at a time running together with the sleep. And here, if you use directly run method, what is happening? We saw like they are considered as separate. So here you can see it is considered as a normal object, not the thread object. So that's why it is just executing the first function, then the second function. So here next method is called join. So what this join will do is like if you have multiple threads, what this will do, this will add up to the the previous thread. If one job is over, okay, next job is this one, next job is this. We can add multiple threads at the same time, but What here it is happening is same. This is almost same, but here it is not considering it as a threading object, like it's normal object, and then it just executes this function. But with join, you can make that possible. Whatever is happening there, that can be used here also. It will do the same thing, but automatically it just executes one by one. So there are two functions. One is with just join, which can throw an interpreter exception error if that is caused. Another one is join with a time limit. Basically, you can, the data type is long and millisecond is the time limit. So two ways to declare or define this function. And our class name is test join method 1 and extending a thread class. And this is the run function. What we are doing is we are having 500 millisecond sleep, and then we are just printing. Now we are printing 1 to 5. And in our main class, we are what we are doing is we are going to create three objects, T1, T2, T3 for our class. And what we are doing is we are doing first starting one thread only, that is T1 dot start. And then we are trying T1 dot join. And then if there is an exception, print that exception. Then T2 dot start, T3 dot start. So this is our program here. We are just using a simple join operation. So what is happening in the output? So 1, 2, 3, 4, 5. And then what happens? Once that one thread is completed, the second and third are like running together. So what this one does, join function, it what to say? You can tell like it stops the other threads until this thread is getting completed. In the first case, like it was like 1, 1, 2, 2, 3, 3, 4, 4 like that, right? So in this place, if we use this join operation, what is happening is this stops or passes the other threads to run, but allows only the thread which is being called by this join function. So in this case, T1 dot join. So T1 is calling the run function, and then it executes 1, 2, 3, 4, 5, and then it shows. But 1 second, I will show you with an example. Then we will know what this sleep is doing basically. So maybe for this output, okay, I'll just try here. Let's see how the sleep shows up here or not. So we have kept 500 milliseconds, right? Let's compile and run. Maybe it might be fast. Let's see. I just ran so fast, I guess. Let me run it my own system. Let's see. We will keep it. We keep the sleep time separate. Maybe 1000. Let's see. 1000 is 1 second, right? 1500 I'll keep. Okay. What is the test join method? Okay. We can try the just sleep method, how it works. Like how we are seeing what is happening with the sleep function. You can see that sleeping, right? It is just taking 1.5 seconds to print the next one. That is what the sleep is doing basically. Like it is making the thread to sleep for our file from the condition which we set. If I keep it 2000, then you can see maybe like drastically. Now also we can see other. If I don't give the sleep, let's do it this way. Let's do 10 milliseconds. I don't think we can observe this, but let's do it for just seeing how that will work. 10 milliseconds. See, this is 10 milliseconds. Okay, you can see the difference. How the sleep function is making the program to wait for some time to execute the statements. So here, one thing what we are seeing is like this join function. If I don't use this join, what will happen is this will just immediately start this. Let's do that also. Just let's cut that part. Maybe I should comment, but anyway, it's okay. I'll just remove that part. Okay. I remove the join function. Now you can see the difference. Like it's just taking it all simultaneously and running it together. 1 1 1 2 2 2 2 3 3, and maybe because of sleep it is just showing like the time. But if I give say 1000, you can see it will take some time to run basically. So now 1 second gap will be there between all of them. Why? Because there is a switch between each other thread. Then again, we have also set 1000. So thread completion is very fast. Like it just executed one on one. One is from T1, another one is from T2, another one is from T3 basically. So all these functions are like playing its role. So that's how you can use the sleep and join. When you use join, it waits until the task one or the thread one gets completed. Then it starts executing that. This is why how we can mention join with time basically here. So here we are using sleep to wait for the program. This is just it will wait for everything because inside this run method. So every start will call this run. So it is going to be for all. But what if we use join with the time? So here the same thing, only what is the difference is we are using a time here. Let's see how that works here. This is time just join 2 right here. Two dot method is our program. It's time method 2 is ours. You can see there is a difference, but if I increase, maybe you can find it out. Let me keep this maybe 2000. Okay, let's keep it 3000, 3 seconds only. So it's not going to be a drastic difference, but thread you can find like a slight variation. Let me recompile and then there is a time variation if you observe between the like join and then it is completed. This will be like starting the other ones. That is the use of this time with join. But again, depends on what time you want to, how you want to take two of the threads and then combine together that way. So let's see what we can see next, and then so naming a thread, we'll see like this concept. So there is a method, right? We saw already how to We saw now what are the methods and how we can use the thread. But to rename your thread, 3.1, 3.2 are just the object name. But you can rename your thread by using set name function. And to know the name, we can know by get name. Usually the default one is like, it will be like 0, 1, and then it goes on. But you can set your name or any name which is very meaningful to the program. That way we can know that, okay, this thread is running. So how do we do that? Is by just creating a thread object and then use this way, like get name. So here you can see someone has named Sonu Jaishwal as the name for the thread one. But when I just run the thread before naming it, get name, it shows thread 0, thread 1. And it also has another function called ID basically. So get ID will give you the ID of that thread. So here they have given ID function, but in the program it is not mentioned. Get ID will show you the ID. It is T1 is 8. And what is the state? It's because this is just running here. That's why it is printing this one. And here after changing this one, it is showing T1 colon the name which we have set. And this is running because we have just called we have not called here, but according to this output, I'm saying there is another call where we are calling the T1 and T2 here. So this is how you can use this function, like get name. If you use, it will not get you the existing one. But if you want to set the name, you can use this way, like object dot set name, then followed by the parameters which you want to mention. So that way you can create name for your thread instead of using the default one. Default one is thread 0, thread 1. So here, if you want to know what is the current thread which is running, we can use the function which is current thread, where T is capital. So in the class name, extending thread, inside run, you can give the thread.current thread. Then what is the thread name? We are just combining all of them to get the name and what is the thread running. So we have 2 threads and we are just starting 2 threads. And what it will do, it will just run this command, right? So what first it will show us like thread 0, thread 1, because we did not set any names. So it is showing the current thread name. But if you have multiple threads, or if you are running them simultaneously using sleep or join, when you run, you will not realize which thread is running, right? So when you set a name, then you can easily identify, okay, this is my thread 1. Thread 1 deals with some analysis like DNA conversion or discounting DNA, and thread 2 is counting from reverse, something like that. So that way you can utilize this concept of current thread as well as setting name to the threads. And next one is thread priority. So far, any questions, any doubts? If you have, please let me know. Any questions, any doubts? You can maybe, like, after trying that AWT, you can try the basic concept of creating thread. I'll just maybe look up to one concept and then we'll stop here after the thread priority. So there are 3 priorities which can be set. One is minimum priority and normal priority and maximum priority. Like these are like constants which is predefined in the thread class. And you all know that constants should be in capital, so that's why it is all set as capital. And the value for this is like 5 for normal, and minimum is 1, and the maximum priority is 10. So whichever is having maximum will be considered as first, and normal is just to the usual one, and minimum means it will be held for the last. So how can we use this priority concept inside our threads? We are extending from thread class, and then we want to know which thread is running, right? As we are setting priority, we want to know which thread is given more priority. So we are just creating what is the current thread, get me that name, and then we are just printing it. And this is what is the current thread printing, and show me its priority basically. One is for name getting, another one is for getting the priority. And the main function where we are creating two objects, M1 and M2, and we are setting the object. These are like thread objects now, right? So we are setting the priority, like it should be thread that minimum priority, another one is M2 is maximum, set maximum priority. And then we are starting the M1 and M2. Let's run it by ourselves and we will check how this works. For example, name is this one. So now it is showing our thread name, which is which is 1 basically, and the second thread is 0. If you notice, you can see there is some variation in the concept of like what we did is like we started the M1 thread, but M1 thread is having minimum priority. Okay, and that's why that thread is not initialized first, and maximum priority is this one, right? So the M2 is getting printed first. So that's why 1 is printed first, printed next. So the next one is like priority of the thread. So priority it is showing 1. This one is for this thread basically. This is not for the other thread. So this is the priority is given to the highest priority set thread basically, like thread dot max priority is given preference. Maybe let's do some modification with this program, and then we'll set. What we will do is we will add this part here. And we'll do priority of thread here itself. And add this part. Since they are in different statements, we'll just combine both. Hope this will work. Let's see. Maybe I'll keep one more thread with normal priority. Yeah, I'll do one thing like M3. I have to create this object first. Normal priority, what is the name? Norm or what? Okay. Norm priority. Okay. create one more object, M3, and then what I'll do, I'll just start M3 first. Save it. Let's see if this one works or not. SQL team will get it. Okay. But I don't know why the normal priority threat is given very like it is not even considered. Okay, 1 second. Which one I said correctly? Right. M2 is maximum priority. So this is being correctly done. But the priority order is not taking this as we expect. Like what to say? Like it is not taking the second normal or the minimum priority in the order, but minimum priority is considered next to maximum priority. Then it is like the normal priority, even though the number is set this way. Let's maybe try one more example here. We'll add one more object which is M4, and then we will set that also to have maximum priority. So I will just mix this one. Let's see. M4 dot start. But again, I think it is how we start basically, and then we are not using any exception, or we are not using any join operation. So we expect it should be giving the priorities first. Let's see how it works in case of here. Okay, this time the normal priority gets first preference, and then the highest priority is not being any value. Like it's just, I think it is based on what order we start the classes. So if I start, so in this case, I started with third one. So third one is having normal priority, and then I'm starting the first one. So first one is having, okay, first one is not taken. Then M2 is taken. So this is getting, yeah, correct only. I think which order which we are placing, so it works in the same order. The start order matters here, even though we set the priority here. But if you move further and then add synchronization concept, then these priorities comes into play where it is valued more based on the priority values. Here in this example, it's just basically based on only the start of it, where we are starting it. Yeah. Any questions? Any questions so far? Any doubts here in the concept of priority? If not, then I think I'll just stop here for today. Is it fine?
Okay, sir.
Yeah.
Yes, sir.
If you have any questions, you can ask, and you can try to complete the lab exercises which I gave last time. Everyone has completed those?
So except the AWT part.
Okay. So make sure you keep everything ready as like for a record copy. I think I have to post that this one, right? The format. I'll just check if I have any record front page. I'll just send. I think I'll post it where they have one copy of all record. I'll just post in Classroom or 1 second. I'll just share the link. I just posted in Classroom. Okay. Record front page, so you can use that for your record purpose. Like keep that in front and then fill in the details. Yeah, that's it for now. You can like have a break and then rejoin to try AWT.